Yeah, so hello everyone. My name is Aleksa, and today I'll be talking to you about Rootless Containers with runC. So I'm a software engineer at SUSE, as you mentioned. And yeah, so let's talk about, first of all, since this is a one-track conference, I can actually tell you that he has some required reading throughout this conference. So as I all know, you all attended all the talks, and we're 100% attentive through each one of them. So, yeah, I'm not going to rehash what any of these lovely people have said. And I'm going to mention some stuff that they've already mentioned, and hopefully you have at least some surface understanding of, so I don't have to go through everything again. However, I will give you a very, very short piece of revision. The Open Container Initiative. Those who watch John's talks, I don't know, maybe I'm a bit confused. Is it about pianos? Is it about programmable pianos? It's not. It's the standards body, as he mentioned. And there are two main components, the runtime configuration and the image format. And it was created in 2015 to standardize container formats throughout the entire container wars thing. And in particular, runC, which is what I'll be talking about today, is the de facto implementation of the runtime specification. And the kind of nice thing is that it's incredibly low level. Well, it's nice for me, in that it allows you to create a container entirely with just a single path where you have your root file system and a configuration file that describes what you want the container to look like on a very, very low level. And this is the runtime that is used by both Docker and Containerd, and we're working on getting other stuff to work, like, for example, cryo and these sorts of things. So let's just quickly start with a hypothetical. Let's say you have a hypothetical researcher who wants to run Python 3 code on a Python 2 cluster, because obviously all universities run Python 2 because they're still stuck in the 90s. And so naturally, what's the solution to this? The person's heard of Docker, so OK, I'll just use a container, package Python 3, run Python 3, all good. But the admin doesn't want to install any newfangled software. And they won't install Docker, they won't install LXC, they won't install Rocket, they won't install anything. And on the one hand, this is quite frustrating. On the other hand, you sort of get their point in that for example, Docker has some access control stuff, but it's not on by default, and you would have to configure it yourself. And these are many different things like this. So what do you do then? Well, obviously, let's just compile everything from scratch. I don't know if any of you have ever tried to compile NumPy from scratch, but let's just say that it involves installing a Fortran compiler, and it's not good. It's not a fun time. So what should our researcher do? And the real question here is, obviously the solution to this problem is not just saying, make compiling of stuff easier. It's, why can't we just use containers, right? And the big question is, what if we could actually create and run containers without any privileges? We can't get them to install anything. There's nothing we can do in that regard. And obviously, it's not actually hypothetical. This was me in sort of late 2015, early 2016, when I'd run into this exact problem. And I've talked to a bunch of people from a bunch of different places, and they all have this very, very similar issue. So how do we solve this problem? So another very, very short piece of revision. I'm not going to go through what they're made of again. We've already had this discussed several times. The important point is that the only thing that actually matters in terms of containers from the perspective of I just want to run a program inside a container is namespaces. C groups aren't required, and as Christian mentioned, that is a very, very long rant we're not going to get into today. But you just want the isolation. And there's actually a very, very cool kernel feature. It's called user namespaces. And it's a very specific namespace in that it allows you to pretend that an unprivileged user is root, or that an unprivileged user has privileges. I've already given a talk about how this all works and how it all operates. And I'm not going to go through that again. You can look it up. But the very, 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 very short gist is that newer kernels like Theodata and later, you can actually create this particular namespace as an unprivileged user, and then you can create all other namespaces inside that namespace, and then you can manage these namespaces, and that allows you to set up a containerized environment without actually requiring privileges in the first place. Some prior art. So this isn't the first time that this sort of idea has been thrown around. LXC does actually had a feature like this, or has a feature like this, but it still requires privileged binaries and processes in certain circumstances, like, for example, managing C groups, but also some networking stuff. And while you can disable it, the the problem they're trying to tackle is not the same problem that I'm trying to tackle, which is I don't want to have anything to do with asking an admin to install something, because that's just a huge time sink in that it's just not. You don't have to install Docker now. You don't have to install some random binaries that will then do some arbitrary modifications to C groups, right? Obviously, that's much better. But there's another example, which is bubble wrap, which is what Flatpak uses. However, it's not actually a full container runtime. It uses most of the same features that container runtimes use, but it's not actually a full container runtime. It doesn't support OCI configurations. It's very, very cool in what it does, but it doesn't actually do the whole hog thing with runtimes. And obviously, the final solution is you can do it by hand, which is very easy, as you can see. I mean, it's actually much longer. It's like 60 lines in a bash script, but let's not look at that slide for too long. So what works? So quite recently, we're talking like a month or two ago, runC got support for rootless containers upstream. So now if you download, not the latest version, if you download master and you build it, you can actually create and run containers without privileges under runC, and it all works out of the box, and it's all tested and all these other things. Unfortunately, due to some kernel limitations and some of the restrictions that we sort of place on ourselves, some things are not possible at the moment. So runC is a tool that you run that has a bunch of subcommands, and I've sort of listed out which subcommands work and which ones don't. The main ones that you care about, running containers, execing into existing containers, deleting them, listing them, running them in a detached mode and things like that, those all work. The things that don't work checkpoint and restore, and anything to do with C groups, which I will mention, I will actually go into a bit more. But sort of the main point is that almost everything works. So what doesn't work? So checkpoint and restore, we use a project called Cryu, which does checkpoint and restore for us, and you can actually checkpoint a container and restore it even on a separate system if you wanted to, and it like encapsulates all the in-memory state and then copies it. Unfortunately, unprivileged checkpoint and restore is not, I haven't tested it at least, and as far as I'm aware, it still requires a lot of kernel work in how it actually restores processes. So at the moment, it doesn't work, but it would be kind of cool to be able to like live migrate processes as an unprivileged user. C groups, let's just not go there. I mean, I only have 30 minutes, and it would at least take 2 hours to go through everything that I have issues with C groups. But the other thing is that network namespaces is another thing that doesn't work if you want to just use, if you actually want to have a network and do things with the network. But the really cool thing about containers is that you can actually create containers without using all the namespaces. This is a Linux-specific thing because every single namespace is separate, so you can just not use network namespaces. All right, and I mentioned there's a runtime and an image component to this whole thing. The runtime, as I said, is only half the story. What about images? Luckily, this is actually basically a solved problem. So there are two main tools that exist nowadays. There's this tool called Scopio, which is a part of Project Atomic and Red Hat's thing, and umochi, which is a tool that I wrote, which allow you to operate on OCI images as an entirely unprivileged user. Well, I mean, their purpose is not specifically that, but these are features that exist in both of them. So you can actually download and convert an image from a registry, and then you can convert it to an OCI image and then unpack it with umochi. Umochi has a bunch of other really, really cool features that I won't get into, but yeah, it's sort of, images are basically done. I actually even made a proof of concept called Orca build, which allows you to build a Docker file without root. So you can build a Docker file using just runC, Scopio, and umochi, which I will now give you a live demo. So, all right, here we go. So I have here, so what I would do if I wanted to download a Docker image, I've created a Docker image on the Docker Hub called Cypher Rootless, and I think it's called Rootless Container Demo or something like that. And let's just say that I'm not going to download it over conference Wi-Fi. So luckily, I have already got it in my local directory here. It's called demo whale. So if I now do Scopio copy Docker archive demo whale.image, OCI image latest. Okay. And so what this is doing is that it's going to take this. What it would normally do is it would connect to the internet, download the image, and convert it. What it's doing now is I already have a copy of the image on disk, so it's just taking the on-disk version, converting it to an OCI image, so taking all the blobs, putting them into where they need to be, and then making it so it's actually a proper OCI image. Yeah, so, geez, extraction takes forever. Anyway, so yeah, so and then actually the cool thing about Scopio actually, you can even pull from a wide variety of other registries, which is kind of nice because it's not actually linked to one particular registry format, and the entire purpose is that you can actually use it as a way of operating on any type of image that sort of exists out there. Okay, so we now have an image, and I'm now going to use Emoji to unpack the image. Okay, so now this is going to extract the image and put it inside a runtime bundle. So as I mentioned, there are two different specs. You have an image spec and a runtime spec. The image spec defines what you would think of as a Docker image or an image in another sort of container sort of ecosystem. And that then has metadata inside it, which tells you how to run it, and then you can convert it to a runtime by extracting all the layers and then then generating the configuration. So we now have this is the configuration, and that's the rootfs, and this is some cool stuff that Emoji does that I'm not actually going to talk about. So what you would normally do is you would say, oh, okay, I can just do I can run. So I can just run this bundle. And I can just run it as root, and I'll run it as root. And wow, it works as root. But obviously, we're not here for that. We're here for running it as an unprivileged user. So now, with upstream runC, I am now inside a container. And this container was entirely created without any privileged helpers, without any privilege at all. So if I type in ID, it'll tell me that I'm root. But in actuality, I am an unprivileged user, and this was all set up entirely without requiring any privileged helpers. So I'm going to give, if I can remember what I called the script. Okay, so so this is just a silly demo I wanted to show you. What it will do is it will download 2 files from the internet. How to take that? It will download 2 files from the internet, and then it will run some analysis script I wrote for my research project, just to show you that you can actually. Here's an example of how I would have done it if I had this at the time. But now if I go to, I'll actually just show you quickly that 2017. I will quickly just show you that you can actually do runC exec. So if I do you can see that I have this container, and then I can exec into it. And if you see, I'm in the same container. But actually, if I now show you now that psaux grep. So as you can see, this process is actually running as me on the host, but inside the container, it's convinced that it's root. And so yeah, so this will show like a pretty picture, but it's not really that important. So you can do so this all works now on like basically all recent distributions, anything later than 3.8, apart from Fedora, but that's a separate issue. And I think it's pretty cool. Right. So should be done by now. Okay, never mind. I'll show you the other cool thing. Oh wait, hang on. Okay, I'll show you the other cool thing, which is Orca build. So you can actually do Orca build is a quick POC I wrote that allows you can actually build. It's kind of like Docker build, but it doesn't use Docker. It uses OCI only. And so I can do now Orca build latest, and I can do output image, and I can build the current thing. So it'll use Scopio to pull BusyBox, and then it'll use Emoji and runC to build the entire image, and you end up with a final image, which is an OCI image, all layered, all set up in the same way. This is all building from like a normal Docker file, and I just realized that downloading a Docker image off the internet on conference Wi-Fi was a bad idea. So yes, okay. Conference Wi-Fi, okay. ignore that. It does work. I did run it before. OK, so let's just bypass that. OK, anyway, here's the cool picture I showed, but it doesn't really matter. So they had some mercy. Let's go with that. So what's next? So I made this website, which you can go to that link to see, and it's a list of all the stuff that I think is still we still have to do for rootless containers to actually make them quite useful, because there's a lot of use cases that you can see where you would want to be able to set something up. You have all this really cool container technology these days, but it all requires privileges to actually do anything. And it would be really, really cool if an unprivileged user could just use it on their laptop, or you could like go on a computing cluster where you don't have root, and you could actually still use some of this stuff. So. So very quick blazing pass through on what kernel stuff is still required. Overlay file systems are still not really possible to use as an unprivileged user. Like when you use images in Docker, when you use containers in Docker, the entire file system is built on top of overlay file systems, and so you have like a bunch of layers. What I just showed was it was extracting it as like a normal directory, like a normal user would, like tar xvf, right? But it'd be really cool if we could use like Btrfs does actually support unprivileged subvolume operations, but not everyone uses Btrfs. Ubuntu supports overlayfs as an unprivileged user, but that's not upstream, and actually the maintainer called that a brave decision. The demo that I showed could connect to the network, and the reason why it could is because it used the host network namespace. Basically, you can't use network namespaces and also have an internet connection due to some privilege problems, and that's fine, but what if you want to like use, I don't know, IP tables? What if you want to, and you'll see in the next slide the crazy ideas I have about that, but basically, what if you wanted to do this stuff? There's no real way to do it. It is actually a kernel problem, but I actually had some very, very horrible ideas how you could actually try to implement VF bridges in user space using tunnel and tap interfaces. I'm not going to go into it because that is actually a horrific idea, and let's not go into that. So. Let's say you're just a regular user and you have access to a bunch of nodes. I want to run Kubernetes on these nodes, but I don't have Kubernetes. Or pick your orchestration runtime of choice, but it's still the same problem. I want to manage jobs across a bunch of nodes. I don't have admin access on these nodes, but I still want to be able to manage them in some way. What do I do? Well, at the moment, you sort of script it yourself with shell scripts. But what if you could run an orchestrator? Right now, the biggest blocker looks like it's networking. Like kubeproxy, for example, does a bunch of very complicated things with IP tables. I don't know whether it's actually possible to do all that as an unprivileged user, but I'm definitely looking into it as like an interesting thing. And most orchestrators assume root. And this is sort of the big problem, is that most people just sort of, when you're writing a root level process, you sort of just assume that you have root, and you just write code as though it has root. And so if you want to actually make it not run as root, it's a huge pain to actually change it so it actually works. And there's a lot of assumptions you have to deal with. But yeah, that's sort of an open question at the moment. The really cool thing, though, is that Cloud Foundry, they recently have been switching their runtime to use runC or OCI stuff. And huge, huge shout outs to the Cloud Foundry guys. They actually have experimental, as it is there, Rootless Containers with their orchestrator. It has some limitations in that it still requires some privileged helpers in certain cases, but it's really, really awesome that they jumped on this, and it's really, really cool stuff. And you can read all about it in that repo. But yeah, it's really cool stuff. So, I mean, why are we stopping at servers? Why can't we just run everything inside a container? Flatpak is working on this, but they actually aren't going all the way with containers. They use namespaces in certain situations to do certain things, but I mean, it's not actually a full container. But it would be really, really cool if, I mean, Flatpak is really, really awesome, but what if we just start putting everything in containers like crazy? And the principle is that if I can run it as my user, I should be able to run it inside a rootless container. And if I run it inside a rootless container, I can actually separate out all of my regular processes. And there's some cool ideas I have about privileged overlay, but I probably don't have time to go into that. And ultimately, ultimate convergence. What if you had desktop applications that had container features in them? Like Chrome uses seccomp, but why can't Chrome make it so when you open it, well, Chrome, whatever, Firefox, whatever you want to use. You open a new tab, and it creates a new container with or at least a new network namespace that is tunneled through Tor, for example. You open a new tab, and suddenly you're in Tor. Or you open a new tab, and suddenly you have like, I don't know. This is sort of still very, very early ideas, but it appears there's a lot of potential here to using a lot of the container stuff that we have on servers to actually use it on desktop applications. But yeah, so that's sort of the ideas. And actually, Jessie Frizzell, she runs everything inside a container on a machine, and she also runs CoreOS on a laptop, which is a very, very brave decision. But she has a blog post where she talks about how she actually has set up her machine to actually use rootless containers and only rootless containers. She was actually using it while it was still an open pull request against runC, so major props to actually trusting my beta code that well. But anyway, she has an interesting blog post, but she's sort of going with that direction, and it's interesting to see where that will go. So some quick acknowledgements. As I said, Jessie, she actually worked on this stuff first, and she had a POC called binCTR, which was like, she sort of took a lib container and commented on a bunch of the code until it ran. And it was really, really cool because she had this idea where you could actually have a single flat binary that you then run, and it has the entire root file system inside it. Eric Biederman and Serge Heilin, they have been working tirelessly in kernel land to get user namespaces and countless other unprivileged things actually working in the kernel. James Bottomley, in particular, he helped me out with some kernel patches to fix the cgroup stuff, which if you want me to talk about the cgroup stuff, ask me later. And he's done a lot of kernel container work, which is pretty cool. So you can get my slides from there, by the way.